Okay, in this video, we want to talk about the cube root function and how to graph it and what the characteristics of that are. So the cube root function, if you look at this green graph, that is what y equals x cubed looks like. So much like we did with the square root function, if we drew the line y equals x and we reflected y equals x cubed over it, we would get this black graph. And that represents y equals the cube root of x. So again, the green is my y equals x cubed, and then I'm going to reflect it over y equals x to get my new graph, or my cube root function of y equals cube root of x. So if you remember when we reflected y equals square root of x, we had a problem. It didn't pass the vertical line test. But this time, I can draw vertical lines anywhere down my cube root function, and I only hit one point. So I don't have that problem. So this time, I have no problems. This is a function. I don't have to erase half of my graph. So when I look at the cube root function, I'm able to work with the whole thing and deal with characteristics of all of it. So let's go ahead and talk about the characteristics of the cube root function. And here it is without the other part drawn on it, so you can see. This is the cube root function. So when you have y equals x cubed, your graph looks like this. But y equals cube root of x, your graph goes sideways. So let's talk about some characteristics. So your vertex this time, or we can call it an anchor point, you'll see why in a minute. Again, it's just at the origin, or 0, 0. Okay, what about our domain? So with your x squared, or square root of x graph, everything was above this. So we only talked about x being greater than 0. But this time, x is both above 0 and below. So we can actually say that our domain is all real numbers. And we represent that with this big, funky looking R. Our range also starts here and goes both this way, and I did it wrong again. It goes up and down. So our range, we can also say that is all real numbers. So for both your range, your domain, all your x values, and all of our y values, we represent it with all real numbers. So now let's talk about end behavior. Remember, end behavior is what happens to y as x approaches 0, or not 0, infinity. So we can say that as x approaches infinity, in other words, as this goes this way, what happens with y? Well, as x goes this way and y is going this, much like with the square root of x graph, they're going to just keep growing. So as x approaches infinity, y is approaching infinity. Well, and on this one, we also have the negative side. So we can also say that as x approaches negative infinity, because this one's going to go this way as well, y approaches negative infinity. Okay, asymptotes. Again, asymptotes are where it's going to be approaching 0, and this one is going to keep growing, so it's never approaching 0. So just like in the square root of x graph, we have no asymptotes. Alright, so what about symmetry? So when we look at this graph, we can't just say, yes, we can draw a line this way and get symmetry, or yes, we can draw a line that way and get symmetry. However, if I could put my finger here and spin this, it would rotate right back on top of each other. If I took this and flipped it 180 degrees, I have the exact same graph that I started with. So we can do what's called rotational symmetry with your cube root graph. So we're going to say rotational symmetry. And those are your 6 characteristics of your cube root graph.